Hi everyone, my name is Deborah Chen and I'm a PM on Azure Cosmos DB. Today's session is on how you can take advantage of elasticity features to optimize your workload to get the best cost and performance. By the end of this session, you'll have 3 concrete strategies you can use to go tune your workloads today. Before diving into these strategies, I want to briefly talk about what elasticity gives us. Elasticity is about flexibility. Cosmos DB is a service that gives you the flexibility to scale up and down as your workload grows and shrinks. And most of the time, this happens automatically without you even knowing. This all happens while we maintain throughput, latency, and availability SLAs. So now that we have this flexibility in mind, let's see how we can take advantage of it. The 3 strategies we're going to talk about today are 1, how you can right-size your RUs by tuning your provisioning. We'll learn about how you can choose between autoscale and manual throughput to pick the one that's best for lower cost. We'll talk about how you can leverage a new preview feature called burst capacity, which makes it easier for you to consume the RUs you already have, and it's a completely free feature. And finally, we'll talk about the importance of choosing a good partition key and how that can impact your cost and performance as well. The first strategy is around right-sizing or tuning your provision throughput. As a recap, in Cosmos DB, you set the RUs that you want to provision, and every second, you're allowed to consume up to that many RUs. Now, typically when we see pain, where we see dissat with cost and performance, is when customers have over-provisioned the RUs relative to what they actually need. So here, for example, if you've provisioned a lot of RUs, but your consumption is down here, you might perceive that you have good performance because you're never running against the limit of this provisioned throughput, but in reality, you're over-provisioning, and this peak here is kind of that dissatisfaction. In contrast, the 2 types of workload profiles where we see the best opportunities to optimize for cost and performance are if you have a workload that's really great for autoscale. So this is actually the majority of workloads in Cosmos DB that have variable workloads. You may not be able to predict exactly what your throughput is, but you generally have a sense of what range you need to be in. With autoscale, Cosmos DB automatically scales the RUs based on what your workload requires, so there's no more worrying about having to scale down when it's not in use. This basically gets rid of this over-provisioning gap. At the same time, if you have a workload that is extremely steady and constant, you may benefit from using manual provisioned RUs. Even with manual provisioned RUs, it's still important to lower your RUs close to what you're actually consuming to get the best cost performance there. So intuitively, I think most customers can have a sense of if their workload is super steady or very variable, but in terms of actually choosing whether autoscale or manual is the right setting for your containers and which one helps you achieve the best cost, I can show you some tactics to systematically analyze that now. I'll go ahead and switch to the Azure portal, and before I get into how to do this, I just want to level set where autoscale is in the portal. So here I'm in my Cosmos DB account in my Data Explorer, and I have a container here called autoscale workload. Currently, it's provisioned with 30,000 max RUs, which is actually a pretty large workload here, so mostly here for demo illustration purposes. It gives a 10x scale range, so I will scale between 3,000 and 30,000 RUs automatically, depending on whatever my workload is actually consuming. Switching between autoscale and manual is as easy as choosing the setting and selecting save. So if you have workloads where after this session you realize, hey, I should really use autoscale, or I should actually switch to manual, you can do that in less than 10 seconds. To determine whether autoscale is working well for you, your best friend is going to be this metric right here called normalized RU consumption. Normalized RU consumption is a metric value between 0 and 100% that tells you how much of your RUs have you actually utilized. 100% full utilization, 0% zero utilization. All these metrics I'm showing you here can be found in your metrics blade. These are all free, out of the box, nothing to configure. They'll be in your account today. Now, with my normalized RU consumption, I can filter to my database and container and see that in the past day or so, I've had hours where I've had 0 usage and hours where I've really hit peak usage at 100%, and then a little bit here in between. I can also look at my metrics to see how Cosmos DB autoscale has scaled. My orange line here is my autoscale max throughput, so that's the max or the limit of what I can scale to. And the blue line here is what Cosmos DB is scaling to. Now, intuitively, this looks like a pretty variable workload. It doesn't seem like I should always be at 30,000 RUs, or my max, but how do we know that for sure? To that end, I'm going to tell you about the magic number that you can use to basically figure out if autoscale or manual is more cost-effective for your workload. That number is 66%. If you take the utilization of every hour in a time period and average up all the utilizations, so some hours will have 0, might be 50, 100, etc. If it averages out to 66% or less, that means that you're actually taking advantage of this autoscale scale range, and staying on autoscale is more cost-effective. In contrast, if your utilization is typically more than 66%, you're always scaling to the top end of autoscale. Autoscale will actually be more expensive than just provisioning your steady throughput there. So changing to manual can save you 33% with very little effort there, while keeping the same performance, because you can keep the same level of max RUs here. So what I'm going to show you now, if this sounds like involves more steps than you want to do, don't worry, we have Azure advisors that actually do everything I'm about to show you automatically, and will just tell you the result of should you use autoscale or manual, and how much money will you save. Right? But if you want to do it manually, you can go here to your collection, filter to the metric, and set the time granularity to 1 hour. So we're going to see at each hour level what the utilization was. You can download the usage here to Excel. And I already have one open here, which I downloaded previously. And you can see for each timestamp, I have that same normalized RU consumption metric. I can basically use Excel to do a quick average. And I see here for my time period, my average is around 47%. This is less than 66%, so I know autoscale is good for this workload. Now, this time period was pretty short. I was only running this workload for about a day or so. So the recommendation is try to use at least 2 weeks, a month of data if you have. Azure Monitor will actually give you 90 days out of the box by default. So if you have longer period, feel free to analyze that time period. Going back to the slides, now that you've seen how to choose between manual and autoscale, I just want to call out 2 of the other scenarios that we sometimes see come up, that if you're running into these, and they're not super common, but if you are, you can fix these right away, tune these, and save money immediately. The first one, like I mentioned, is if you're on autoscale today and you're always scaled to the max, that's actually a sign you should use manual provision throughput. If you go ahead and do that, you'll save cost immediately by provisioning the same amount of RUs, but just getting a lower unit rate. The next scenario we see as well is even for customers who have used autoscale, sometimes their usage is still even lower than that 10% of their max RUs. So if autoscale is limiting you here, and then the 10x scale range is here, and your workload is down here, that means you can actually lower this whole range and shift quite a bit. That means that for the hours where you're not using Cosmos DB, you'll actually be able to pay even less. So if your utilization is averaging to less than 10%, in the time period, you can save on your costs by just lowering that autoscale range. In terms of how aggressively or how conservatively to lower the range, it's up to you. We tend to see a lot of customers lower by 5, 10% at a time until they finally find the sweet spot where the utilization is in the range that they're looking for. In this next strategy, I want to talk about how you can adopt a new preview feature called burst capacity, which lets completely free feature, which lets you use previous unused capacity that you already have to handle future spikes. This works with both manual and autoscale. The scenario we really want to address here is imagine you have a container, or the container's physical partitions have a small amount of RUs on them, right? You may have workloads that are idle for some period of time. And today in Cosmos DB, the moment that you try to use more than the RUs you have, whether it's the manual RUs or your autoscale max scale range, you immediately see 429s and get throttled, right? The fact that you never used the capacity, let's say in the past hour, didn't really help you there. With burst capacity, we are changing this. Burst capacity is a feature that basically lets you collect that unused capacity and apply it to handle future spikes. As a result, requests that otherwise would have been throttled will actually now go through. With burst, you can burst up to 3,000 RUs max on a partition, and this feature is enabled at the account level. So here's a graphic to show this in more detail. Here I have an example container that's provisioned at 1,000 RUs autoscale, so scales between 100 and 1,000 RUs. And for a period of time, this orange line is my actual RUs consumption every second. So here I'm actually using my diagnostics logs here to see what my RUs is at the second level. For a period of time, I have some unused capacity, and then So now I made my workload such that I have a sudden spike. Now blue line here is the max autoscale RUs I'm allowed to scale to. But you actually see here for a little bit of time, for a few minutes, my consumed RUs is actually more than the provisioned RUs. This is basically burst capacity in action. These spikes are being covered by the unused capacity I accumulated over here. And you can accumulate up to 5 minutes of idle capacity worth. Now, burst capacity doesn't last forever. Eventually, if you have sustained traffic and try to stay at this peak throughput, you will run out. So then we see us going back to our normal workload levels. Let's actually go see a demo of burst capacity in action. And I just want to reiterate that burst capacity is a free feature that you can enable today on your accounts and hopefully see some of your throttles, if you're getting throttled today, decrease. Here in my Azure portal, I have an account that I've created to show burst capacity. And first, in my features blade, I've enabled burst capacity. So you used to have to sign up with the Cosmos DB team for this. Now you can just turn it on and off here on your own. So I already have this enabled at the account level. And I have the autoscale container here that is provisioned with 1,000 autoscale max RUs, which scales between 100 and 1,000 RUs. Now in my Visual Studio here, I've set up a simple console app that's just going to do a bunch of inserts against this container. So I'll run this, and typically, and I'm going to really try to push this to get the most throughput I can. So really try to hammer this collection. Now I'm able to achieve around 250, 260 writes per second. We can see that my average throughput per second basis is actually more than 1,000 RUs. This is burst capacity in action. I basically wasn't using this container at all for at least 5 minutes before this session. So you can see that I'm able to scale beyond or to use more throughput than the baseline of what I have here. So these are all the free RUs, if you want to think about it that way, that burst capacity is giving you. Now I can go to my diagnostics logs as well and show you that same view earlier where I have, for a while, I have my blue line here is my provisioned max I can scale to. And for a period of time, you can see I'm bursting above around 3,000 RUs burstability and then back down to my normal workload level. If you don't have diagnostics logs enabled, which by the way is a great way to see at a per second basis a lot of information about your workload, you can also see this in a more 1 minute or 5 minute aggregated view in the built-in Azure Monitor metrics. So here I have a graph set up that shows the total requests split by capacity type. So here in the blue line, these are all the number of requests that were fulfilled with my provision capacity, regular capacity. And here the orange line is the amount of requests I was able to do with burst capacity. So the other way to think about this is if I didn't have burst capacity, every single one of these requests would have been throttled during this time. So burst capacity is a really powerful feature that lets you use unutilized capacity that you already had to cover future spikes. Finally, for the last strategy, I want to briefly talk about the importance of choosing a good partition key. Now, choosing a good partition key can be a topic that takes a whole hour. So here, I just want to demonstrate and give an example and demo of just how powerful choosing a good partition key can be and how big of an impact it has on your cost and performance. At a high level, a partition key in Cosmos DB helps Cosmos DB route all your requests efficiently, whether you're doing reads or writes. With good partitioning, the same request would consume fewer RUs than if you pick a bad partition key. And if you consume fewer RUs, that means you can provision fewer RUs. And because you're billed for what you provisioned, your bill is also lower, right? In contrast, if you have a bad partition key and now all your requests consume more RUs than the same with a better partitioning strategy, now you're going to have to provision more RUs, which is higher cost. So let's actually see a demo of how with the same data set, the same operation, how with two different partitioning strategies, one more optimal than the other, we can actually get significantly better performance as well as cost. After that, we'll wrap up with some general guidance on how to choose a good partition key. Here back in my Azure portal, I have two containers set up. One that is partitioned with a synthetic key, which is a concatenation of two properties that exist in my document. Let me expand this out here. And here I have a scenario where I have a bunch of retail stores and I'm logging transactions that have happened at each store. Okay, so you can see I have a synthetic partition key here, which is the combination of store ID and transaction ID. Now, typically, I might do this because I'm worried that a single store might have more than 20 GB of data. That's the most amount of data that can fit under one partition key value. So synthetic keys have been a common workaround for many customers who have these scenarios. This also applies if you have like a multi-tenant scenarios where some of your larger tenants might have a lot more data than the other smaller tenants, right? Now, this is with just Cosmos DB today, a synthetic partition key. And I will show you the same container, same data, or different container, same data, but now I'm using hierarchical partition keys in Cosmos DB. Hierarchical partition keys let me partition or subpartition my data with up to 3 levels, and it helps me get better data distribution when I have workloads that have different sizes per tenants. So in this case, my tenant, you can think of it as a store ID. It could be an actual tenant, like a customer. If I have stores that might be larger than 20 GB, some smaller than 20 GB, hierarchical partition keys is what allows me to partition efficiently, but still scale beyond that 20 GB number. So here, I'm actually going to run the same query against both of these containers. Now in Cosmos DB, if you choose a good partition key and you have a workload that has a lot of reads, if you can include your partition key in your query, that query will always be more efficient. Cosmos DB will know based on the partition key that you've included, it'll know exactly which of the underlying physical partitions stores that data, only check that one and return the data to you. In contrast, if you don't provide the partition key, it's going to have to look at every single physical partition, which adds overhead and also latency to the overall request. So I'm going to run a query first against my synthetic key container. And I'm going to run the query that gets me everything related to store ID 42. Okay. So I got around 100 results back, and this whole thing consumed 40 RUs. Now notice I didn't provide the partition key in my query, right? My partition key is the store ID, transaction ID, synthetic key, but here I've only said store ID. So this is a cross-partition query that's actually going to all the underlying physical partitions, and that's what's adding to this cost to return this data here. Now in contrast, if I am able to provide my partition key in my query, in other words, if I partition my data in such a way that that's possible, I can run the same query here. And because I've done that, and we only need to go to the subset of physical partitions with that data, the same request or the same query is only consuming 12 RUs. So for the same operation, right, if we now consume 1/3 of the RUs we need, that means that for the same level of RUs, I can either do 3 times more of that same request, or I can lower my RUs by that same amount and therefore save all of that cost, right? So this is one example of how powerful choosing a good partitioning strategy for your workload can be. Okay. Wrapping up with some general guidance. Again, this is a topic that could probably take a whole hour, so I just want to give some general guidance here. Feel free to check out our myriad of resources on the same topic. In general, you want to choose a key that optimizes for your workload pattern. If it's read-heavy, you'll follow certain guidance. If your workload is mostly writes, we have different guidance for that. In either case, you'll want to pick a partition key that gives you a good distribution of storage and request volume. If your workload is read-heavy, you'll want a partition key that you can include in most of your queries. So in that store example, we did store ID and then transaction ID as our partitioning strategy, and we can include the store ID in most of our queries. If you have a workload where you otherwise would have used synthetic keys, we recommend you use hierarchical partition keys now in preview. If you have a write-heavy workload, it's recommended to choose a partition key with high cardinality or a lot of unique values. So these are scenarios like IoT, device ID, vehicle ID, things that have basically GUIDs are the most random way you can really distribute your data evenly across the container and get the most throughput there. All right, so to recap, today we covered 3 strategies you can use to tune your workloads. First, you can tune your actual provision throughput and try to use autoscale when applicable. We also talked about how you can use a new burst capacity preview feature, a free feature that lets you use unused capacity you already had to handle future spikes and reduce 429s or throttles. And third, the importance of checking your partitioning strategy to review if it's optimal for your workload. Thank you for listening, and please enjoy the rest of the conference.